Problem 2.21. The forces acting on the sailplane are its weight, W, which is equal to minus 500 units in the J direction. This is in pounds. The drag, D, which is equal to minus 200 units in the I direction, plus 100 units along the J direction. This is also in pounds. And the lift, L. The sum of the forces W plus L plus D equals 0. Determine the components and the magnitude of L. Alright, so the first thing that I'm going to do is to place all the information that the exercise is given to me within the... I'll write down all the information, right? So it is telling me W is equal to minus 500 units in the J direction. This is in pounds. It is also telling me D, which is drag, is equal to minus 200 units in the I direction plus 100 units in the J direction. And the lift L is the one that I'm looking for, the components and the magnitude. So I'm looking for the components and the magnitude. All right. They're giving me a statement which is W plus L plus D equals 0. So taking into account this statement, all I have to do is to solve it for L, for the lift. So the lift is going to be equal to minus W minus D. Alright, so they're telling me that L is equal to minus W, which is equal to minus 500 in the J direction, minus D, which is minus 200 units the I direction, plus 100 units in the J direction. Alright, everything looks good. So there is something that I like to do for when I have negative symbol before a parenthesis, and is to change all the symbols that I have within that parenthesis. What does it mean? That for when I want to do this, I'm going to eliminate that parenthesis, changing the symbol that I have right here. So at the beginning, I have right here a negative symbol. Because of this negative, this becomes a positive number. The same thing goes for these other parentheses. So right here I have plus 200 units in the I direction, minus 100 units in the J direction. Right, so right here I have J, and I. Alright, so I can add these two, but these I cannot because I don't have any other number along the I direction. So L is going to be equal to 200 units in the I direction. 500 minus 100 is equal to 400, so plus 400 in J direction. Right here I have the components of the vector L of the lift. And all I have to do for me to get the magnitude is to evaluate the square root of every single component evaluated to a second power. So the magnitude of L is going to be equal to the square root of 200 square plus 400 square. And the magnitude of L is going to be equal to square root of 200 square plus 400 square. 447.2135. I always use both significant digits after the comma. And this is in pounds. As well, this is in pounds. Alright guys, this is how you can solve this exercise, taking into account some knowledge of the magnitude, and the addition and subtraction of components giving a vector.